This episode of Perl deals with binary numbers, or the binary number system base 2. Now, it's easier to understand base 2 if we first review base 10, or the decimal number system, the ones that we use because, as some people say, we have 10 fingers and 10 toes. Now, the base 10 number system has 10 symbols that represent values. And those symbols listed here are 0 through 9. Here we have in the first row the symbols 1, 0, 2, 4. Now we intuitively recognize that as the value 1024. But why? Well, each position, starting from the right and working our way back, has a larger value. So if we go to the rightmost column, we have the digit 4. Now, that position is equal to the number base 10 raised to the 0th power. Any number raised to the 0th power is 1. So I have 4 ones. The next position is 2 of something. I have 2 10s raised to the 1st power. Why 10? It's our number base. Now, raised to the 1st power would be the number 10. Any number raised to the 1st power is itself. So I have 2 10s. So far, looking at the rightmost 2 columns, I'm looking at the value 24. Now, in the third column, moving from right to left, we have a 0. But 0 what? 0, 10 squared. 10 raised to the 2 power, or 10 times 10, which would be 100. So I have no 100s. That's our 100ths place. And then the leftmost column has a 1. But 1 of what value? 10 to the 3rd power, or 10 cubed. 10 times 10 times 10, which is 1,000. So the 1 is in the 1,000ths place. The 0 is in the 100ths place. The 2 is in the 10s place. And the 4 is in the 1s place. So we have the value 1024. But that's not the only way to represent a value. We could use another number base, and we're going to take a look now at the binary number system, or base 2. The binary number system only has 2 digits, 0 and 1. Here we have a representation of 1 byte of computer memory. That is 8 binary digits. They are 1, 0, 1, 0, 1, 1, 0, 1. What does it mean? Well, let's find out. Again, starting from the right and working our way to the left, each place has a value based upon the number base. And this time, the number base is 2. So it would be 2 to the 0th, 2 to the 1st, 2 to the 2nd, to the 3rd, to the 4th, to the 5th, 6th, and 7th. Okay? So, let's move on. 2 raised to the 0th power is 1, as is any number raised to the 0th power. So I have, in this rightmost column, 1, 1. I have 1 unit of 1. In the second column, I have the 2s. Remember, 2 raised to the first power is 2, just as any number raised to the first power is itself. Next, I have 2 squared, which is 4. And then 8, 16, 32, 64, and finally 128. So I have 1 unit of 128, 0 units of 64, 1 unit of 32, 0 units of 16, 1 unit of 8, 1 unit of 4, 0 units of 2, and 1 unit of 1. So, all I have to do now is add them up. 128 plus 32 plus 8 plus 4 plus 1. That's my number converted from binary to decimal, or from base 2 to base 10. And it's the number 163 in base 10. Now, notice the way I'm representing the number here. The 10 is subscripted, representing the base of the number. Now, if I want to take this number, a binary representation of 163, and I want to use that as a numeric literal in a Perl program, I would precede the binary digits with 0b. 0b, lowercase b. That would tell Perl this is a binary number, and it would recognize that it's the same thing as a decimal 163. And that, my friends, is all there is to it.